In this video, we're going to go over what enantiomers and diastereomers are. If you look at this chart from your book, you can see diastereomers and enantiomers here on the bottom. Diastereomers and enantiomers are in fact a type of isomer. So they have the same molecular formula, but they're different in some way. Remember that constitutional isomers had different connectivity. Stereoisomers, however, have the same connectivity. So that means that they have the groups attached to the same carbons. However, they're still going to differ in some way. You can see that enantiomers very specifically are a mirror image, whereas diastereomers are not mirror images. Let's look at an example of some enantiomers. Enantiomers are what we call non-superimposable mirror images. That means that while these molecules are mirror images of each other, and hopefully you can see that here, we can't put one on top of the other. They don't quite match up. This is a little hard to see by looking at these pictures, so let's check out some models. So let's take a look at these models. Here you can see that they are mirror images of each other. Now I'm going to rotate them, and again hopefully you can see that they are mirror images of each other. Okay, so what does it mean to be non-superimposable? I'm going to try to take this one and put it on top of the other. And you can see that the red and the blue don't match up. If I rotate it, now the red and the blue match up, but now the hydrogens don't. One's going up and one's going down. So that's what it means to be non-superimposable mirror images. They're mirror images of each other, but when I take one and try to put it on the top of the other, they're not exactly the same. As we just went over, enantiomers are a pair of molecules that are non-superimposable mirror images. You can see an example of a pair of enantiomers shown here. Diastereomers, then, are stereoisomers that are not enantiomers. One good example that we've already seen is cis and trans. You can see that both of these molecules here have the same molecular formula, and the chlorines are connected to the same carbons, but they are not mirror images. Let's go over an example of a superimposable compound. A superimposable compound is one that if you build its mirror image, it's exactly the same molecule. That's what this picture is trying to show you. Here's the molecule, and here's its mirror image. And if you take the mirror image and rotate it just a little bit, you have the same thing as the original molecule. So that is what we consider to be a superimposable compound. You can tell that you have a superimposable compound if two or more groups attached to the carbon are the same. For example, you can see on this molecule here, you have two hydrogens. Then if you build the mirror image of the compound, it will become superimposable. Now let's take a look at these molecules here. You can see that they are mirror images of each other. And if I rotate them around this way, you can see that they line up perfectly. So these molecules are superimposable. Here are a couple more examples of enantiomers and diastereomers. You can see this molecule over here on the left is a mirror image of this one on the right. So they are enantiomers. They are also both cis cyclohexanes. The relationship between cis and trans, however, are diastereomers. So if we take this molecule and we just flip one group so it's away and we get to trans, now the relationship between these two molecules are diastereomers. Same thing over here on the right. If we take this methyl group and flip it, these are diastereomers. This trans molecule on the bottom left is a mirror image of the one on the bottom right, and so the relationship between those two are enantiomers. The top one over here is also a diastereomer of bottom right, and bottom left is also a diastereomer of top right.